Welcome to a presentation on accelerating SOC verification with SOCX-Verifier using a software-driven approach. In contrast to block and unit-level designs, SOC designs have an embedded CPU core which changes the verification landscape significantly. It's not enough to verify if the hardware works, but also verify the software's integration with hardware. In SOC verification, in addition to providing stimulus at the interfaces, software running on the embedded core is needed to simulate the DUT from inside. Hence, this can be termed as software-driven verification. An effective SOC verification requires coordination between test bench and DUT. As of now, there are no methodologies and very minimal automation for test creation. If you look at the current practice, verification starts with running basic tests and few driver-level scenarios to confirm if the IP transacts data, at which stage RTL is handed for validation. In the validation stage, the entire focus shifts to getting a commercial OS booted on the SoC. Any issues found during the process is either masked by software or fed back to verification. Each incremental step in fixing such issues leads closer to OS bring-up. As part of this process, much of the driver and application code gets developed, refined, and fine-tuned. So what ails current practice? At the end of the validation process, there are no guarantees that all hardware-software issues have been explored. This means that complex hardware-software issues still lurk, and the reasons could be hardware-software tests require coordination of DUT and test bench event activity. They are laborious and effort-intensive to create. The lack of automation tools also means that multiple use cases of the same scenario remain untested. Lack of any methodology during test development results in limited reuse. This means that existing scenarios cannot be combined to increase concurrency in the system. Lack of knowledge of how an OS would sequence calls to an IP results in orthogonal tests. The lack of a controllable verification test bench makes control and debugging of issues effort-intensive. The end result, with no means to test complex hardware-software interactions, such issues remain hidden, and therefore much needs to be achieved at validation time. So what does SOCX-Verifier Solution offer? SOCX-Verifier Solution is based on three concepts: automation, methodology, and language. Automation is based on pre-built and auto-generation of test bench and DUT components. The generated test bench and software components makes it easy to coordinate and control hardware-software scenarios, thereby boosting productivity and comprehensiveness. With scenarios comprising of software, it makes it important to have a methodology for test development. SOCX-Verifier provides a structured test development methodology based on extensible base classes. This enables scenario combination, reuse, and use case exploration. Methodology is drawn from UVM and OVM and is verification friendly. Users can spec verification intent to SOCX-Verifier in a subset of system Verilog language constructs. Higher level language primitives like fork, mailboxes, semaphores, etc. provide the necessary abstraction to think in the problem domain. Programming language interface to C is also provided to reuse legacy code. Using SOCX-Verifier approach, users can spec driver level or application level scenarios with ease. Coordinating test bench DUT event activity is much easier due to pre-built and generated components. The ability to reuse scenarios and combine them enables comprehensive testing of complex hardware-software issues, resulting in higher bugs exposed early and having higher confidence in OS bring-up activities. SOCX-Verifier Automation Solution comprises of SOCX-VIP test bench component and SOCX-OS software component. SOCX-OS is a C library which handles all channel communication details and scheduling for the test application. Depending upon the scenario intent, SOCX-OS can span from a simple command interpreter to a multiple thread scheduler. The SOCX-VIP architecture is similar to traditional VIP and is OVM-UVM compliant. SOCX-VIP and SOCX-OS form the infrastructure to enable coordination and control of scenarios. In SOCX-Verifier, hardware-software verification intent is specified in System Verilog-like language. The scenario intent is translated into C test software and SoC-OS components. Relevant portions of this intent is translated into test bench components which plug with the SOCX-VIP. The top-level generated sequence runs on SOCX-VIP, which coordinates and controls test bench DUT activity. Memory channels are created in a portion of system memory to exchange data between SOCX-VIP and SoC-OS. User-defined data like sequence items and tool and user-defined data flow through these channels. The management of the channels is done by SOCX-VIP and SoC-OS and is transparent to the user. To summarize the feature set, SOCX-Verifier generates all the repetitive and boilerplate OVM or UVM code for test bench components. Depending upon scenario combination, multi or single-threaded code is auto-generated. For an effective software-driven verification, SOCX-Verifier provides all the means to coordinate test bench and DUT event activity. This makes it possible for software to launch sequence on VIPs. Software can also raise or drop objections while executing. In addition, there are predefined OVM or UVM events on which test bench can attach callbacks. Users can also define their events or software coverage points. Finally, to summarize, SOCX-Verifier provides all the necessary automation in terms of generating test bench and software components, thereby enabling testing of complex hardware-software interactions. Methodology ensures scenario combination, resulting in top-down development and maximum reuse. All this enables studying and verifying complex interactions early for a comprehensive verification, thereby having higher confidence during validation and OS bring-up activities.